I thought this was a pretty fun problem. The question is, what fraction of the first 1,000 positive integers can you write in this format? And I'm going to tell you what this symbol means. It means round down to the nearest integer. So for instance, if x was like 8.4, well, 2x would be 16.8, and we would round down to 16. Now, if x were just a little bit bigger, say 8.55, then when we double it and round down, we would be over 17, so we'd round down to 17. Now, just for ease of notation, when I talk about, say, the floor of 2x, it's either going to be the integer 2 times the floor of x or 2 times the floor of x plus 1. I'm not going to write the floor just to make things a little bit simpler. Because all that really matters for the instance for the 2x is whether the fractional part is above or below 0.5. And similarly, if you're going to multiply by 4 before rounding, you need to care whether the fractional part is above 0.25 or between 0.25 and 0.5, etc. And each time you cross one of these tiers, at the end, your answer is going to get 1 larger. Now, the decimals for 1/6 and 1/8 are kind of annoying, so I think it's better to use fractions. And so I've got all the possible fractions here on the screen, and what we notice is that sometimes things line up. For instance, the first threshold we cross is right here. We're going to add 1 to our sum, and then here's another one. But then when we get to this threshold here, we actually cross it for 2 different terms in our sum. So whatever integer we had above this threshold, we're now going to get 2 more when we move forward. You can see that similar things happen as we go further down the line, and you can see that the integers we get, we're never going to get something of the form 20 times a number plus 3, or 20 times a number plus 7, 8, or 9. In fact, if you count up all the numbers, we're only going to get about 60% of the numbers this way, so the answer to the original question was 600.